The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Hey guys, and welcome back to Lighting Controls Podcast. We have a fantastic guest for you today who has been on the show previously and took a little bit of offense, not really, but a little bit, to the fact that we constantly tell people, or not tell people, but we constantly talk about the fact of DMX is not as well known. We talk to a lot of our audience that maybe doesn't understand DMX as well, and we try to not avoid the conversation, but sometimes not get too deep in the weeds. We certainly have in the past, but our guest today wanted to come on and sort of have some of those conversations and took a minute to remind us that more of our guests understand DMX than we give credit for. So here we are today, but before we jump into it, let me take a minute to remind everyone today's episode is presented by the LCA, the Lighting Controls Association.
And it's financially supported by the National Association of Innovative Lighting Distributors, or NAILD. Check out our website, lightingcontrolspodcast.com. Got all of our episodes, a whole lot of other cool stuff, including information about the new NAILD LSC certification. So if you want to learn about lighting controls and get certified, it's worth checking out. But also, huge shout out to our sponsor for this episode, which we could not do without your support, MaxLight. Especially their CMAX lighting controls platform. It's definitely worth your time if you're unfamiliar with this. You should check them out, maxlite.com/CMAX. It's a true plug and play platform, and I'm not just reading the bullet here. Like I mean that. Like, it's true plug and play. What's really cool about it is that they have this patented USB-C receptacle that they put on all of their MaxLight fixtures, so you can quickly swap out your lighting controls devices so that you go from, basic lighting control capabilities local in your space, or you can grow it up to be a completely networked system, and you don't even have to choose right away. You can swap that out later on, upgrade your project throughout the process in a phased format. So it's really worth checking out. It's a great product. But at any rate, let's get into the conversation. So today we have David. David, for people who haven't seen you on the show before, do you mind just giving a quick breakdown on who you are and what you do?
By all means, happy to do so. My name is David Fox. I am a training and outreach specialist with ETC. I've been with ETC for a little over 26 years at this point. Prior to that, I spent a lot of time in the entertainment lighting space as a master electrician, console operator, general all-around working on live theater, film, television, and live production and event sound. That was a large portion of what I did. I remember when DMX was the new hotness and just starting to replace analog. So I guess that makes me you can call me old. I tend to refer to myself as old enough to remember when, but still young enough to lose the occasional "I'm so old" that conversation. I referred to it as somebody yesterday as I'm old enough to remember before DMX, but young enough to have never touched a saltwater dimmer. So that's kind of where I live.
And I'm going to stop you there and
all right,
just
fair
ask
enough.
you to describe to our audience what a saltwater dimmer is, because I think that is one of the most unique things that has ever been brought to the lighting controls world.
Fair enough. So back in the olden days, when people were looking for ways to dim light, there's a lot of different technologies, and this could be a whole other podcast. So I'll tread lightly
100%.
here. But once electricity was being used in theaters, and they needed to find ways to control lighting, there were a number of different things that were looked at and tried. And as the industry started moving towards adding a ton of wire and varying it to do resistance or variacs or things of those nature, one of the techniques that was used was you would have a big pit of water or a big tube of water, and you would immerse your electric coils into the water. As we know, water is a conductor of electricity. So the deeper or the shallower that you put the wire, the brighter, the more current you would have being able to flow through the wires to allow you to dim things. However, the reality and the science behind all of it is water itself is not truly a conductor of electricity. If you were to take a glass of distilled water and you were to put two wires into it, one being energized and one leading off to your fixture, you're not going to see anything happen. What actually is happening in the water and what actually makes it a conductor is the minerals inside of the water. And I learned this because David North, who used to work at ETC and was a great friend of mine, used to do this demonstration where he would pour a styrofoam cup full of distilled water and nothing would work. And then he would stir some salt into it and then it would work. So that's a saltwater dimmer. But when they were utilized, and Paris Opera House was one of the places that did it, the Metropolitan Opera House in New York used them for a brief period of time before it switched over to DC. But imagine, if you will, a room that was full of insulated metal tubes built into the floor, where you had spigots that were able to dispense boiling hot water and a pile of salt and shovels, because what you constantly ended up having to do when you used these dimmers was to trim them by either adding more water or adding more salt so that they dimmed consistently. And you used hot water because it dissolved the salt faster.
Right.
Thankfully, technology has improved since then, and that's not something that we run into probably at all, right? The only time I've ever actually seen a functional saltwater dimmer was on a table to explain this entire principle.
Right. But I mean,
yeah.
it does emphasize that complete lack of safety consideration when it came to, well, the performance is what's more important than the safety of the people in this room.
That's really true. Yeah, I mean, I didn't mention the bare electrified wire and bare non-electrified wire and pulley system that you manually raised and lowered things in.
Right.
But I
so at any rate, I mean, theater is one of those places where it's like, nope, the show must go on, literally, regardless of people's safety. So
yeah, and I think it's interesting. Go ahead.
Oh, that I was just gonna say, that being said, I mean, it's curious how DMX has evolved from that world, because of the fact that it really wasn't the show must go on mentality that created the DMX solution to a problem.
And that's very true, right? I mean, as I was about to say, and as it all kind of comes back from the building of what came before, right? And I think it's worth taking a second to mention what control protocols were like before DMX, which really created the genesis of why DMX ended up getting created, and ultimately why it's still around. And I suppose I call out to Javid Butler, who I know has been on this show a few times, because I haven't been saying DMX 512 enough that he's probably shaking his fist at me at the moment. So I will try to remember to say DMX 512 because that's what it is actually called as a protocol. But before that came about, you had a number of different ways of being able to control what the output of your lights was. Saltwater and a pulley being one of them. Thankfully, that was not utilized in a lot of different places. Hand piano boards where people varied resistance was there. And some of that was dimming. But I also look at a lot of that as being control, because you had to manually control things. And as we started, as the industry started moving into some form of go ahead.
Hang on a second, because that is a really good distinction, and actually hits on topics that we were talking about in the most recent or one of the more recent episodes that we had with Chris O'Shea, or I had with Chris O'Shea while Ron wasn't available, which is the definitional standards that we have. And so that's a really interesting distinction to say. Dimming isn't necessarily control, even though it is technically controlling the illumination or the the electricity, but it's not really the interface in which you are controlling things. And so
100%. Yeah. Once we moved into once if you think about all of the fixtures, whether it's in the entertainment marketplace or an architectural marketplace or a commercial marketplace, they all have some form of dimming built into them, right? An
Yeah.
LED fixture is going to have a ballast, and that ballast is handling the dimming. Or you've got a dimmer rack that is, with silicon control rectifiers and modules that are handling the dimming or the varying of the voltage. But control is a completely separate beast from that, right? How you control it is really a different thing. And again, when we look at the history of things, but prior to DMX coming out, what you were really looking at in terms of what was control was very manufacturer specific and very all over the map. Or
Yep.
once we moved away from one handle per dimmer, right, where you had board operators that were running things with their hands and their feet, or specially customized pieces of 2x4, what you started to run into electronic dimming, and a lot of that was some form of analog voltage.
Yep.
Where you had a device that was creating the source of that voltage. 0 to 10 volt is kind of where it came to prior to DMX, but I've seen everything from 0 to 10 volt to 0 to negative 36 volts, where you're applying resistance to control the power, as opposed to a positive where you're sending voltage out. Where you had a lot of different analog controls, so you were still very much wire per dimmer. And now you were varying the voltage. One of the great things about the old 0 to 10 volt dimming systems was you could troubleshoot your entire system with a 9-volt battery if you needed to, because you could simply connect a 9-volt battery between a hot and a common, and you would see the light turn on. I will stress for people that are coming from more of the modern commercial architectural market, or are used to dealing with LEDs. When we talk about 0 to 10 volt now, it's different.
Yeah.
And the reason that it's different is, we used to deal with 0 to 10 volt sync, which is where we were, or sorry, 0 to 10 volt source, where it's source. I'm old, sorry. Was 0 to 10 volt source. And in 0 to 10 volt source, your console was generating that 0 to 10 volts as you moved a fader, which controlled the output of the dimmer. So as the dimmer got more voltage, it would turn on higher. What we deal with now when we talk about 0 to 10 volt was the opposite, which is 0 to 10 volt sync, which is that the dimmer ballast device, whatever you want it, whatever it actually is actually generating the voltage, and whatever your control source is pulling that voltage down. So at maximum resistance, you are looking at 0 volts across the two wires, which is off, or the minimum dimming point for that device. I don't want to use off, because we all know that can sometimes be a word of lies.
Off needs a relay, essentially.
Well, minimum output, right? Minimum regulated output is the way I try to refer to it, because 0 volts may or may not actually be off. And at 0 resistance from your control source, you are looking at maximum output for that device. And that's a little different. But to get us back, so we had a ton of different control protocols that were out there, and there was a lot of analog control protocols. And as microcircuitry became easier to buy, cheaper, better to put into electronics and control sources like consoles, you started to run into more digital protocols, and everybody was coming out with their own protocols. LMI had a protocol, which was one of the big manufacturers. Strand Lighting had a protocol, which was another one of the big manufacturers. Electro Controls had a protocol. Kliegel had a protocol. I could name probably 10 more. And some of the people in our audience that are familiar with this would do it. And it created a very big problem. And the problem that it created was you had to go manufacturer specific to put in any kind of a lighting system, because manufacturer A's dimmers didn't have a means to be able to talk to manufacturer B's console.
Well, I liken it to the way we are in the commercial lighting control system in North America, because it's the same kind of situation where the vast majority of manufacturers, you have to have brand X's equipment to control brand X's dimmers.
We're kind of back where we started in some ways, and when we look at where where did we start with this, we're not talking about that long ago, right? To put it in perspective, we're really talking about the mid to late 1980s is really when a lot of this all started coming together. But what was happening was a number of not only manufacturers but dealers and consultants and specifiers such as yourselves kind of came back to the industry and said, no, right?
Mhm.
Interoperability really needs to exist here. I don't want to be tied to a specific manufacturer for anything. So
Right.
a group of folks got together from a couple of different companies and a couple of different rental houses. Shout out to Steve Terry for being one of those people who was kind of driving some of this. To come up with a new interoperable standard, and that's where
Mhm.
DMX really kind of came from. It's based off of, they based it off of existing communication and technology, and utilized a protocol that was going to not only be as open source as possible, which allowed as many manufacturers who wanted to implement it, but also was a very robust signal that would work. Analog
Mhm.
was great, but you
Mhm.
ended up, if you had 96 dimmers, you had this trunk snake, and as soon as you
Yes.
broke one wire, you were done, right? So they wanted something that was
Right.
going to be a lot easier to work with. And
So how
you know,
how did
go ahead.
there's probably a lot of people listening who are just going, there's no way that this in reality happened, because everyone, if you think of today, right,
Hmm.
try and get everyone in one room to make this sort of universal decision to say this is what we're doing for the industry.
Yeah.
That would not happen today. It won't happen today. How
Well, and
how did they actually make it happen?
how did they pull it off? Well, I could make a lot of jokes and make a lot of references that I'm not going to. And you're absolutely right, right? Because this is one of the biggest things that we're seeing. The elephant in the room of this conversation, unspoken, but exactly true to what you're saying here, is ACN, right? And I'm not going to get into that
Mhm.
in this presentation or in any of our conversation here, because that is not DMX at all. It kind of falls into a different thing, but that is, ACN, for people that don't know what those initials are. I'll catch myself before you catch me. Is an advanced control network protocol with a new design of being, let's create an interoperable protocol so that lots of devices can work together. And ETC has been really trying to drive that forward as a protocol, but we've run into, exactly as have other people, right? It's not just
Yep.
solely an ETC thing. That is not a fair statement. And I don't want people to walk away from this thinking ETC is the only one that has worked on this, because that is not true at all.
Right.
There's a lot of people that are trying to work on this, but we're finding exactly what you were just talking about, Ron, which is that getting that interest to happen today
Mhm.
has been a lot more difficult. So that protocol, then a new ratified standard, still doesn't really exist. What made DMX work and what got DMX to really get ratified at that time was kind of a couple of factors. Number one, you had a smaller group of people that were looking at it, because that part of the industry
Yep.
was a little bit tinier, and they weren't trying to look at every possible manufacturer, right? You have to realize
Right.
this was at a time where connecting DMX to a moving light, or connecting DMX to a fog machine, or connecting DMX as the backbone for a control system didn't exist, because
Right. Right.
some of those technologies didn't exist, but also there was no unified protocols, right? So you
Mhm.
had a smaller group of people that were really invested in it. It was really
Yeah.
dimming and control manufacturers, and more importantly, and I think this is what really pushed it, is it was large rental houses like Production
Mhm.
Arts,
Mhm. Yep.
that had gear and came and really were saying, we need an interoperable standard. I can't carry 7 different consoles and 7 different dimmer racks in
Yep.
inventory, or my customer doesn't. I can't legitimately go to a customer for a new installation and say, okay, you have to buy only this manufacturer's stuff, and anything else you
Right.
try to add to the system won't be able to talk to one another. And I really think that's what drove a lot of this, which, if you look at it with some of the other technologies and protocols that are out there, I think it's one of the reasons why you're seeing a lot of stuff with 0 to 10 volt, right? It's a
Mhm.
standard that everybody can understand and work with, or Dolly to a certain degree, which is becoming more and more of a thing, especially in the architectural and commercial marketplaces, where it's an interoperable standard that people recognize a need for. And you've had
Mhm.
pressure from a good group of people to say these are the reasons for it. And I look
Right.
at DMX at this point as another protocol or another language that kind of exists within that operating sphere. They all have their benefits, they all have their disadvantages. One of the
Mhm.
reasons is I'd reached out to the two of you specifically to have this conversation was, I felt that more often than not, when you were having a conversation talking about something, someone would introduce a concept about DMX or start talking about DMX as if it was a known and understood thing. And
Mhm.
you would have to stop and say, okay, well, for our audience that doesn't really understand this protocol, let's try and explain this. And I
Right.
think when my initial reach out to the two of you was to say, let's do a podcast called Not Another DMX Podcast, right? Which really
Right.
kind of explained what this was in a way that, either people could refer to it or audience members that are not familiar with the interworkings of protocols would get a better understanding of why this is around. And we can
Yeah.
definitely talk more about that as we work our way through the conversation, right? So, in a lot of go ahead. You look like you're about to ask me
Well,
something.
yeah, no. So, I mean, as it pertains to DMX 512, and
Mhm.
we do, we try to make sure that everybody, if they're jumping into an episode for the first time, they've never listened to a previous episode, there's no continuity between our episodes. And
Sure,
so,
100%.
as a result, it's really important that we make sure we give people some soft landings with terminology, because otherwise, lighting control specialists just throw jargon out there like it's
Oh
known
Yeah.
yeah.
to the world, and
Our,
it's
our
like,
entire
whoa, no,
industry is
hold on.
initials and acronyms, right? I mean, I work for
Yes.
ETC. I'll leave it at that.
Right. So, but so if you were to talk to somebody who didn't know anything about DMX 512, where would you start?
I think what I would start with is, and when I've done a class that's similar to this, where I kind of talk about, what my elevator pitch, if you will, for DMX is DMX 512. I gotta remember to keep saying that. I apologize. It's just I forget.
It's never
Um,
gonna catch on.
I'm not gonna. You're not gonna hear those words come out of my mouth, because I think it should, and I should be using the right words for things. We have enough initials in our. It's a fact.
Fetch is never gonna happen.
Exactly. So my current pitch for DMX, if I'm doing my elevator pitch for DMX, or if I'm referring to it for people that don't necessarily understand it, is I refer to DMX at this point as a last mile protocol. Because when you look at any modern control system, most of
Mhm.
your modern control systems at this point have some level of networking, or Ethernet based networking, or Bluetooth
Yep.
mesh, or some other thing that is actually letting the big things communicate with one another. But ultimately, you need something that is going to travel down the wire to the driver, right? Because not
Right.
every single driver is 100% wireless, or not every single driver has its own control integration circuitry built into it. It needs to
Mhm.
get a thing telling it what to do. And
Which is
DMX
what
at this point,
IES has defined as a back-end protocol.
yeah, you can call it a back-end protocol,
Mhm.
and I look at all, of all the big protocols that are out there, 0 to 10 volt, DMX, these are
Yep.
last mile protocols, right? Once you've gotten
Right.
to the thing, before you get to the thing that makes light go, you have a protocol that needs to talk to it. And that's
Right.
kind of where DMX lives. DMX falls into the sphere of good control protocols, and a lot of people have looked at it as, well, it's this niche thing, or I'm only dealing with theater and therefore I don't need DMX. The thing that DMX gives you that some of the other protocols out there don't, is it gives you an ability to control multiple facets, or parameters, if you will, of a
Mm.
fixture
Yep.
in a single line of control. So if I have a
Yeah.
color changing fixture, or if I need to modify white points, or color temperature, or movement, or fan speed, or any of the things that a fixture could do these days, one of the things that DMX gives you that some of these other protocols on the marketplace don't, is the bandwidth within that protocol, inside of that wire,
Mm.
to control more than one thing. 0 to 10
Yep.
volt, everybody's comfortable with it, everybody's familiar with it, but you're really looking at a very analog setup, right? You are
Well,
varying a
it's
voltage
just
which is
like,
controlling a single thing.
yeah, it's like the bad old days of theater again, where you need giant, arrays of cable because you have so many control points.
Exactly. And
Whereas
as soon as you go ahead.
digital allows it to be packaged digitally as opposed to physically.
Right. I totally agree with you. And and some of the protocols that are out there, Dolly 2 is different, and I will say that right now before any of your Dolly 2 fans are like, "Wait a minute, dude." And Dolly 2 is certainly different, but Dolly, Dolly was one of the other digital protocols that has been big in this area.
Mhm.
But even at that point, unless you were looking at something like Dolly RGB, which was kind of an offshoot of
Mhm.
standard initial Dolly, you still weren't really looking at something that had this ability, right? And this is one of the
Right.
things. This is one of the reasons why DMX is a good protocol, or DMX 512 is a good protocol to be looking at that last mile to get you where you need to go. For that, for that reason, right? You've got a single wire that has a lot of
Yep.
bandwidth to be able to handle data and to be able to
Mhm.
handle multiple individual parameters or individual channels of control, so that you can run one piece of wire to a fixture or a line of fixtures and be able to control not only intensity but all of the individual color parameters that exist in them at the same time. So
Mhm.
that's one big advantage to it. The other thing that I think is a big advantage to talk about is it's a tiny wire, and it's
Mhm.
utilizing a communication protocol that, at the end of the day, one of my taglines is DMX wants to work. It's
Mhm.
based off of the RS-485 protocol, which was chosen specifically because it supports a differential signaling. For those of you that aren't familiar with that, what it means is you have three wires. You have a data plus, a data minus, and a common. And the data plus and data minus are sending the exact same thing in opposite of each other, and utilizing the common as a reference point. So every device that receives DMX has essentially, and I'm simplifying this, okay? So
Right. Yeah.
to be clear, there's essentially there's essentially a comparator chip that lives inside of that circuitry that says, does the waveform on the plus match the waveform on the minus? And if yes, I'm going to consider it valid data and do something with it. And if it
Mhm.
Mhm.
doesn't match, I'm going to ignore that portion of the signal that I'm receiving, because clearly there's some other issue. Which means if you're running into interference or noise or transient
Yep.
voltage or any kind of harmonic dissonance, um, it gets ignored by your devices, which is fantastic, right? You don't have to worry about, you should never run it next to high voltage, but if for some reason it is adjacent, you're not going to run into those kinds of issues because the signal itself really wants to work. The other really nice thing about it is, while you should have a data plus, a data minus, and a common, it doesn't need that comparator. I've seen systems where one of those two lines has gone down and the system continues to want to work. DMX wants to
Mhm.
work. It's a very reliable, and it supports long distances. So you can
Yep.
connect multiple devices together over a significantly long distance. We can talk about all the different determinations, right? The typical rule of thumb is about 1,500 feet. And
Mhm.
that, but to clarify, that's really based off of the wire that is recommended for its use, right? The standard
Yes.
wires that people recommend are either Cat 5 or Cat 6, or a specialty wire like Belden 9729 or its equivalent. And at that point, you can get your 1,500 feet. But I'll tell you, I've run DMX down barbed wire for about 2 feet, and it works, right? Because the signal wants to work. I heard about a trade show a number of years ago, where some folks in the Swisson booth, they make a bunch of DMX tools. They make some diagnostic tools. They were running DMX down pieces of wet string, and they got it to run for about 50 feet. Right? It's
That's
it's an
amazing.
electrical signal, and it's a
Yep.
comparative signal, and it wants to work. And this is why so many manufacturers continue to use it, and so many manufacturers like it, is because
Mhm.
these are some big pluses, right? Most of the time when I have run into DMX issues, it has
Mhm.
not been the wire. As long as you follow some of the
Right.
rules, and I think we should
Yeah.
absolutely take some time in this to talk about those. And as
Totally.
long as you're using appropriate wire, once you have your infrastructure in place for DMX 512, it is not going to be the wire that is causing your problem. It is either something with your
Right.
receiver or it is something with your transmitter. But the infrastructure is good and solid, and that's one of the
Mhm.
reasons why, when people think about it and say, oh, well, why should we use this? These are some of the reasons, right? It is interoperable
Mhm.
across a lot of controllers and a lot of
Mhm.
different devices that can receive it. And the strength of the protocol is robust enough that
Hmm.
it is going to work in a lot of places. It was designed for the entertainment industry, right? It was designed for
Right.
an industry where the show must go on, but it was also designed in an industry where you are looking at a lot of changes happening very
Hmm.
quickly that need
Yep.
to be happening under a very specific set of absolute timing
Right.
requirements. And do I need that in my convention center when I'm trying to tell the lights to go from 0 to 50%? Probably not. But right, I mean, it
Yeah,
doesn't
I
have,
mean,
you know,
you might
no
run
one's
into some unique conditions, but for the most
Yep.
part, you're right. Nobody's taking a stopwatch and being like, "Okay, is this actually
well,
20 seconds?" Like,
right. We're not trying to match the beat in Hamilton as the lights are changing in the convention center, right? But the protocol is there and it supports that. The
right.
other thing about the protocol that I think is advantageous is because of the way it works, it's constantly repeating. So it
Yep.
is not sending information as needed. It is a constant stream of information. Now it's not super fast, right? It's 250 kilobaud. It's faster than the modem I had when I was in college. It's a lot slower than
Right.
what we're seeing when you look at regular Ethernet. But at 250
Right.
kilobaud, what we're looking at is the packets are being sent essentially 44 times a second. So
Hmm.
if you are running into a situation where, for whatever reason, whether it's voltage or uh, any of the other things that could cause a packet to drop or a device to not see a packet, chances are that is going to be imperceptible both to the electronics that are actually outputting the light and to anybody that is in the room looking at it. You're
Yeah,
not
I
going
mean,
to
it's
notice that the
essentially
packets have been lost.
when we're comparing streaming versus, message-based protocols. You're basically comparing a squirt gun to a fire hose.
Yeah,
So,
absolutely.
Yeah.
a squirt
Yeah. Yeah.
gun, you pull the trigger and then it sends out, water or data or whatever. But with
Hmm.
DMX 512, you basically are hooked up to the fire hose and it's just spewing data out
Constant,
into the
constant
ether.
stream of data. Yeah, one device talks, every other device listens, and that's an advantage to it. You've got
Hmm.
512 slots for information. I know, like, some people refer to it as 512 channels or different things. I like to think of it as slots, right? I have
Hmm.
a packet that is being sent, and I'm sending that packet 44 times a second, and that packet contains 512 slots in which I can place some kind of level information. So
Right.
you have a fairly big chunk of what you can send out, right? So you can support multiple fixtures if need be. Not 512 on a single wire. I'll talk about that, but you can support a lot of information happening very
Yeah.
quickly.
Well,
And
so
most
let's
devices, yeah, please.
let's get into the rules because I think my favorite phrase about DMX is it works until it doesn't. And so
Hmm.
yes, can you run
Accurate.
it over barbed wire? Can you run it over wet string? Sure. And that'll work until it doesn't.
Until it
And
doesn't,
so
right? And yeah, and
we
I've had
have
this
these
similar conversation when supporting people that want to break the rules.
right. So I mean what are the like recommended rules? What are the
Sure.
hard rules? What are the like best practices?
I look at all of those as being the same thing, quite
Okay,
honestly.
Yeah.
fair enough.
I look at all of it as
I don't
being
disagree
fairly
with that.
synonymous. Because again, it works until it doesn't. And
Yep.
in my personal life, I'm a rule breaker, and sometimes in my professional life here at ETC, and those of you that have known me for a while know I can kind of be a rule breaker sometimes. But when it comes to data protocols, no siree, Bob, right? And especially with something like DMX. Yes, all the things I've talked about are great in that it wants to work and it can be incredibly tolerant. But these are the rules, right? The real rules are respecting the wire distance. So if we're going to
Yeah.
assume that we are using some kind of Cat5 or better wire, or we are using a specialty wire like Belden 9729, which is a specific stranded shielded cable. So you're looking at
Yes.
a cable
And twisted pair.
with a shield that has twisted pairs that are twisted to a specific amount of twists per foot. Each individual pair within that cable is individually shielded, right? So it is a specialty cable, and Cat5
Mhm.
lets us get past that. But even so, whether you're using unshielded twisted pair or shielded twisted pair, and I recommend shielded twisted pair when you're dealing with DMX, you are using there are specifics to that cable. Can I use something else? maybe, right? Barbed wire, string. People have tried audio cable, all of these different things. The data is going to want to go down the wire, but wire requirements are a hardcore rule, right? Follow these wire requirements. The second one is distance, right? Assuming you're using the right wire, we are talking about 1,500 feet total wire length maximum. Will it work longer? Possibly. But again, if it starts to have problems, the first thing I'm going to tell you to do is to shorten the amount of wire in the system. There's a rule that falls into play that's a 12-inch stub rule off of that. So before people are thinking like, well, but now I have, and I'll talk about topology in a second. But there's a rule in that says you can stub out about 12 inches or so. And we've, if you've ever worked in any kind of a theater environment where you have a DMX line that is running from your control booth to your dimmer rack, that may be a fairly substantial line. And somewhere in the middle of it, you have a box in the middle of the auditorium so that you can set up the console for a technical rehearsal, or a place where the lighting designer and the programmer want to sit not in the booth to be able to run things. So there is some acceptance in that you may end up putting a stub in the middle of that long wire and you still have that wire in the system. And so there's some acceptance that may happen, right? Ideally, it shouldn't be more than about a foot of wire. We've all done more than a foot of wire and it's worked, right? But so there are some stub rules that fall into that.
I mean, but with the stub rule, I mean, that's where best practice comes into play, because
absolutely.
If you had your choice, you wouldn't have a stub. You would just have direct runs for everything.
Right. But there's a recognition that that's not always possible, right? There's just for a variety of reasons you may not be able to do that. You got a really big fixture, you may have 12 inches of wire between where that connector is and where you're actually getting to the circuitry inside of it. Now that would be a really big fixture, but it could happen.
Not that they don't exist,
right?
No, but it's important with wire length too. Like when you're talking architectural fixtures, like sure, you can get to the 1,500 foot limit, but when you start talking about theatrical and you're terminating at a wall plate and then you're going to all your fixtures, you have to account for that distance in that total footage. So like, I guess this is where best practices come into play, right? Like I typically, this is me personally, if it's Cat 5, regardless, because depending on the manufacturer and this and that, if it's Cat 5, I try to stay to 1,000 feet. And if it's 9729, 12 to 1250, I'm usually comfortable with. But 1,000 feet is a good number because it gives me plenty of headroom on the other end.
Absolutely. And, I've seen a lot of facilities over the last decade that have not used a Belden or a specific wire, but they wanted to use Cat 5 to future-proof their system. And in some of those places, those facilities have done one of two things, and one of the which is either just used it, or in some of those places they're using it, but they're also putting in different lengths, because ultimately if you take Cat 5 or Cat 6 and you say, okay, well today it's DMX, so I can go 1,500 feet, but 5 years from now I'm going to actually want to replace this with an Ethernet based system. You can't go 1,500 feet between nodes in an Ethernet-based system. So you'll end up with a lot of 300-foot stubs that then go to a box that then goes to another 300-foot stub, and that's one of the things to run into. So wire length is indeed there. The next one is topology, and I'll hit the most controversial one last. But the next one here is topology, which is that DMX needs to be wired in a daisy chain. You go from device to device to device. So you have your transmitter, you go to your first device, you come out of that first device into your next device, you come out of that device into another one. It is a direct daisy chain of devices with some form of termination in your last device, whether that is an active terminator, which is DMX is typically either wired to a connection point in a device, or it is terminated into a 5-pin XLR cable. 5-pin XLR was chosen at the time because nobody else was using 5-pin XLR for anything. So it was a way to make a purpose-built cable that no one was going to confuse with an audio cable or a fog machine cable or an AMX cable. Right. So you have a daisy chain of devices where you go from device to device. Last device in line needs a termination. That termination is typically 120 ohm resistor. That is specifically chosen because that is the nominal impedance of the specialty wire. So if you're using Belden 9729, it's 120 ohm wire. or it's got a nominal impedance of 120 ohms, so you put a resistor on the end. And you want some kind of a resistor on the end, because one of the things that can happen with DMX or with these kinds of protocols is what's referred to as reflection, which is if the data goes to the end of the wire and there isn't anything to absorb it, it can bounce back. And then you can start running into two very valid signals that are floating around on the wire, and we end up with something that I like to technically refer to as icky bad. The other rule here, and this is the one that I think is the most controversial, right? So feel free to at me anywhere you want on this one, is the number of devices in the line. And this is a place where people break the rules all the time. But the standard says that the number of devices on the line is 32 devices total. That is one transmitting device and 31 receiving devices with a terminator on the end. And that is not what your manufacturer told me, is something that I hear, or that not what my manufacturer said, is something that I hear from a lot of different people.
Right.
Because there's a number of reasons that 32 device limit was created. Some of it was based off of the amount of voltage that was being generated and the power consumption of the circuitry inside of the individual receiving devices. And as technology has changed, that has changed. So devices that used to take, what I'm going to refer to as 1 unit loads worth of that voltage, there's now half unit, quarter unit, eighth unit, because the technology's gotten smaller. And some people have looked at that and said, okay, well, if they're all half unit devices, then rather than having 32 devices, I can now have 61 devices, or they do the math wrong and they say I can have 64 devices. Because again, you always have to count the transmitter in that list of 32. It's not a transmitter plus 32; it is 32 total. And that can, and again, voltage wise, electrically, are you falling within the power consumption portion of the standard? 100%. But you're not necessarily falling within all of the data portions of it, and that can become an issue. So this is a place where there's a lot of conversation about this, especially in architectural marketplace or commercial marketplace, where having only 32 fixtures in a line doesn't seem right. To that, go ahead.
I'll argue that from a technician standpoint. 31 devices in a line is plenty, because any more than that, and if you have an issue in that line, good luck. Good luck. It just takes forever sometimes to troubleshoot. Just even 31 devices in a ceiling. Yeah.
I'll pick on 0 to 10 volt in Dolly, right? You can have 64 devices in a Dolly loop, and if one of them isn't working, now you have 63 other devices that aren't working, right? 31 is still a lot. And again, I'm using Dolly as an example. I'm not picking on Dolly in any way, shape, or form.
No.
They're all protocols.
I mean, you can't call brand X's proprietary protocol out, because then
I'm not trying. Yeah, and I'm not.
I was picking on them, right?
And I'm not. I'm using it as an example of allowable numbers, right? I mean, an advantage to Dolly 2 is you can put more devices on the wire.
But
as a technician, when you're troubleshooting, that's just more devices to look at troubleshooting. But again,
we're running low on time here.
Yeah.
So
yeah, for sure.
I want to give you opportunity to talk any more about rules before I do a recap, and then we'll hop into it. But
100%. These are the big rules to look at, and just to recap them as a bullet point for people. We're talking about a specialty wire that needs to be used, whether it is Cat 5, Cat 6, or one of the Beldens. You're looking at 1,500 feet, 31 device, one transmitter, and up to 31 receiving devices with a termination on the end in a daisy chain topology. If you follow these rules, if the electricians who are installing the system follow these rules, if you put this together, you're going to find a reliable, interoperable system that wants to work. And if you need more than 32 devices, there are plenty of devices that exist out in the world, which are referred to as an optosplitter, which is essentially a way to take a single line of DMX in and turn it into multiple lines of DMX out. And I've seen some that do 2, I've seen some that do 5, I've seen some that do 8, there's ones that do 16. How many should it split out to? It really doesn't matter. It is passive in the system, so it doesn't count as a device. And it gives you essentially another 31 devices that you can talk to. So when you're in a system
on the cable distance.
and a reset on your
Right.
cable distance because it's regenerating the signal. So
Yes.
if you have 150 house light fixtures that are all DMX that all need to be controlled, but you're still going to stay within that 512 slots in a universe of DMX. You have the ability to drop optosplitters in line and give you the flexibility both with wire and with device counts to be able to build an operable system. The trick is knowing this and following these rules. And I think the place where most people get burned and therefore feel that DMX is a protocol that is too special or too specialized or too unreliable is when someone isn't following these rules when they're putting the infrastructure and putting their system together. And that's why I'm a big advocate for it. And again, it's a last mile protocol because there are other ways to be able to transmit that data, right? We could have a whole other conversation if we wanted to about streaming ACN, which is a network-based version of that protocol, which gives you multiple universes of that, or RDM, which is kind of the hotness that ties into this, which is which is a carrier signal protocol that lives within DMX that talks in between the packets to give you bidirectional communication. That's another reason, by the way, you don't want to have more than 32 devices in your system. If you've got 152 devices all trying to talk at the same time, nothing happens, right? Because no one can hear each other. But well, again, these are the rules.
Yeah, I think you did a really good recap on the rules. So I'm not going to delve into that in my recap, but I do want to recap the rest of what we talked about here. And I definitely think we need to have a part 2 for this podcast.
For sure, happy to do it.
There's so much to talk about when it comes to DMX. There's so much to talk about with any protocol, but DMX has such a unique history, such a unique dynamic to it, and it really still is very applicable to a lot of the permanent installation projects that are out there when it comes to lighting controls. But when we're looking at it through the lens of history, at least, we are looking at the theatrical side with DMX because that is where it originated from. And the reason it originated from is because of the same issue we have right now in the permanent installation world in North America anyways, where everything's proprietary. It's very much like you had a Strand house back in the day. You have a brand X building now. And so there is frustration with that. The model works. I mean, it's not that the model is a bad thing. It's just that it creates frustration when you want to either replace a component, use a different feature, it's very difficult to work with a proprietary system if that proprietary system needs to be modified with other equipment. So the interoperability is
100%
the
agree with
issue
you.
there.
I 100% agree with you. I mean, I work for a manufacturer, right? That's no lie. And we manufacture control products, and we manufacture dimming products, and we manufacture fixture products. And do we manufacture products that meet every single need in every single building, in every single situation that you could possibly run into? You're both going to tell me no, right? Because you're buying more than just ETC stuff, right? It's a reality. As a manufacturer, I can't meet every single need. And there isn't any manufacturer out there that really can. So having an interoperable signal and having an interoperable protocol gives your customers that flexibility to pick what they want and what they need with the reassurance that it can talk to each other. And that's why one of the reasons why I'm really glad that DMX is understood in this part of the industry, and DMX 512 is a protocol that people can look at in these places. And a lot of manufacturers use it as kind of their fallback protocol or their specialty protocol. It's not really that special anymore, right? I mean, this is a protocol that's been around since the 80s. It's been around longer than Ethernet. Okay, it's not special anymore. It doesn't need to be that super special thing. It's something that I think everybody can use and utilize, and the circuitry to put it together isn't that difficult inside of devices. But you get exactly what you said you're looking for, and it helps. The limitations that it has definitely affect modern lighting systems, and I think that's a place we could talk about in another conversation for sure.
For sure.
But it's as a last mile protocol, and that's why I think of it that way. It's when you need to get from all of the stuff that you've done to get your data where it needs to go to the things that make light go. It is a very reliable, very robust, and ultimately, if you follow the rules, very easy protocol to work with because DMX 512 wants to work, right? At the end of the day, it wants to work. All right. I feel like
Yeah.
I can climb off my soapbox a little bit.
No, David, that was. Thank you. That was great. I'm sure there are some people who started listening to this and just went, "Where is this going?" And I'm sure there's a lot of people who are possibly more confused than they may have been before. But
Oh,
I
I hope not.
promise you,
Yeah.
I promise you, DMX is not hard. There are rules to any system and any
Hmm.
wiring. You plug in a computer at your house, there are rules to that network cable. We don't always think about them, but those rules exist, and it's the same for DMX. And it really
Hmm.
is very simple and very easy. And if you follow recommended practices and stay under those wire lengths and device counts, you will have zero issues. I promise you. Just follow
Totally
those
agree.
easy rules and you'll be good
Yeah,
to
it's
go.
like
David,
5 things and it works, right?
that's it. Thank you so much for your time today. It's
Oh, my
fantastic
pleasure.
conversation. I will close us out and remind everyone today's episode is presented by the LCA, the Lighting Controls Association.
And it's financially supported by the National Association of Innovative Lighting Distributors, or NAILD. Check out our website, lightingcontrolspodcast.com. Got a lot of information, all of our episodes, and information about the NAILD LSC, as well as huge shout out to our sponsor for this episode. We could not do this without your support. MaxLight CMAX platform, a great solution for interoperability, luminaire level lighting controls, networked capabilities. Definitely something worth checking out if you are unfamiliar with them. So check them out, maxlite.com/CMAX. But thank you for joining us here today. And David, thank you. This is a great conversation.